Today I'm back at the Itaipu hydroelectric power plant. The last time I was here, back in 2017, the video was a huge hit. It's already gotten over 11 million views. Hindu. Now we're back in Foz do Iguaçu in Paraná State to visit two places that keep this power plant safe and running. Places very few people ever get to see. And this time we've got special authorization, something that was much harder to get back then. Drone footage. Wow. This is simply the largest power plant in the Americas and the third largest in the world. That massive concrete wall you see behind me is the dam, a structure built to hold back or control a river's water. Here at Itaipu, they harness the force of the Paraná River's water to generate electricity and power millions of homes in both Brazil and Paraguay. It's worth remembering that this is a binational plant. It's located right on the border between the two countries. The structure we'll visit today is the Spillway, that giant waterslide looking thing. This is where those iconic Itaipu images are taken, the ones showing massive torrents of water gushing out. That happens when they release excess water from the reservoir, and that's the path I'll be taking down. But before we get there, we'll see where the plant structure was planned and what keeps it standing strong. For that, we're heading down to elevation 20, right at the dam's foundation, beneath the Paraná River. Since we're descending deep into the dam, it's helpful to explain how they measure floors here. Everything is measured in elevations height above sea level. Up top, for example, at the dam's crest, the elevation is 225 meters above sea level. We're now at the dam's entrance at elevation 144. The Paraná River's original river, the river's natural bottom, is roughly at elevation 40. So if elevation 20 is 20 meters above sea level, that means it's actually 20 meters below the river.
And that's exactly where we're headed.
Access to elevation 20 is highly restricted. Only a few Itaipu technicians are allowed in here. Only professionals who monitor this area can enter, and for safety reasons, they always work in teams of at least 2. But we managed to get special permission to show it to you. This place was created when they drilled shafts and tunnels to investigate the plant's foundation. The foundation itself is solid basalt rock supporting the entire structure at the very bottom of the river. They conducted this investigation to determine whether the rock could support the full weight of the structure. As in fact, during construction, they had to inject concrete into certain spots to reinforce the base. After the plant was completed, they kept using those tunnels, which became these galleries where engineers and technicians study the rock and monitor the structure. That's because the dam is like a living organism. It needs constant monitoring, just like us. Depending on age or temperature, you might want to curl up in a corner when it's cold or stretch out when it's hot. But here, that happens with multi-ton concrete blocks that are also constantly in contact with water. This behavior was accounted for right from the design phase. Engineers don't just calculate how much energy will be generated, they also analyze how the physical structure will behave. Because it was designed to withstand water infiltration, floods, droughts, turbine failures, and even earthquakes. That's why it has over 5,000 drains to channel seepage water and more than 3,000 instruments to check whether the structure is behaving as planned. This one here, for example, is a triaxial extensometer. It can detect rock movement in all 3 directions. To simplify, there are 3 main types of instruments: those that measure water infiltration and how much water is seeping through, those that indicate the forces acting on the structure, and those that monitor whether the structure is shifting or deforming. Here at elevation 20, we have a flow meter that measures how much water is passing through the structure. It might seem odd that water leaks through, but that's normal. No structure can completely stop water without allowing at least a tiny bit to seep through. The key is knowing exactly how much. A bit higher up, we reach elevation 40, the original riverbed of the Paraná River. If I were a fish back in the 1970s before the dam was built, I'd be swimming right here. At this level, we can see piezometers examples of pressure sensors. They monitor foundation areas starting from elevation 8 way below elevation 20. Put simply, they act like scales that measure how much pressure the structure is under that, and that pressure comes from the water pushing against the dam. These instruments are part of the dam's continuous monitoring system. It's not just spot checks, they're also periodic comprehensive surveys.
One example is the geodetic survey conducted outside. So let's head up.
Here, they measure the dam's external movement, and yes, it's normal for the dam to shift slightly depending on the time of year. It might move a bit sideways, forward or backward. For this work, they use equipment that looks like a cross between a camera and binoculars. These are total stations and levels that measure angles and distances with tenth of a millimeter precision. Each point is recorded and compared with previous data, creating a historical record. This way, even tiny movements can be detected before they become a problem. This prism here on the Spillway, for example, is one such reference point. It's one of the targets they aim at from about a kilometer away, give or take. Another thing they keep a close eye on is how much water arrives at the plant, because ultimately that's what makes everything work, and that's the job of the hydrology team. They forecast the volume of water expected to arrive here over the next few days. And their predictions are highly accurate because Itaipu sits at a Y-shaped junction with two upstream dams, Porto Primavera on the Parana River and Rosana on the Paranapanema River. So, the water reaching Itaipu is the sum of what flows through those two dams, plus any rainfall between the river's confluence and Itaipu. There are 41 rain gauge stations monitoring rainfall across the entire region. Knowing how much water will arrive lets them estimate how much electricity they'll generate. More water means more power. But what if there's too much water? More than the plant can use? What happens then? That's where the spillway comes in. It's the dam's primary safety feature, like the overflow pipe on a water tank that prevents it from spilling over. It's a critically important structure, which is why it's closely monitored by the civil engineering team. Itaipu operates as a run-of-the-river plant, meaning there's very little variation in the reservoir's water level. Incoming water must keep flowing downstream, and it can leave in two ways. The most common and most valuable for Itaipu is through the turbines generating electricity, as we saw in the previous video. The other way is through the spillway, which doesn't generate any power, but this release is necessary to prevent water from overtopping the dam. It's a way to control flow and let the water follow its natural course. The spillway can handle a maximum flow of 62,000 cubic meters of water per second. That's roughly 40 times the flow of the nearby Iguazu Falls. To achieve this, it has 3 chutes, those slide like channels with 14 gates in total. The gate behind me is 20 meters wide and 21 meters tall, and behind it the water is nearly at the top. From here, it feels very secure. Practically no water leaks out. It's designed so the water pressure itself helps keep the gate closed. In this chute, water drops 430 meters. So, down here at the end, there's a ramp, a sort of curved basin designed to slow the water's momentum. Just imagine the speed it reaches by the time it gets here. Without that, it would completely erode the Parana riverbed downstream. They just told me that down here at the end, the water can reach speeds of 144 kilometers per hour. Now that would make one awesome water slide. Oh. Here's a suggestion for a new tourist attraction in Foz do Iguaçu. You glide down smooth and then launch yourself into the Parana River. Normally, the area I'm standing would be completely filled with water, even when the spillway isn't operating. It usually forms a kind of lake here, but it's been drained to allow for maintenance. You can see the water line from that white streak on the concrete. The chute is inspected every 6 months, and during these checks, they look for cracks or anywhere on the spillway that needs repair. You've probably noticed by now that Itaipu is a place of extremes. There's even a lab that performs microscopic analysis of the concrete's health. They extract samples like biopsies and examine them under a powerful scanning electron microscope. You can even see the crystal structure of the concrete. I think it's clear now that the spillway isn't just Itaipu's postcard image with those dramatic gushing water shots. Sudawa, it's one of the most critical structures for ensuring the safety of this massive dam and regulating water flow, because in the end, controlling water means controlling power generation. Back in 2017, the last time we came here, Itaipu was practically carrying Brazil's entire electricity production on its back. Today, it remains just as important, but in a different way. It now ensures stability for Brazil's entire electrical grid. We now have other energy sources in the system, solar and wind, but their output varies throughout the day. So, when there's no wind or the sun goes down, it's hydroelectric plants like Itaipu that guarantee the country's power supply. Thanks to the flexibility of hydropower, Itaipu is ready to deliver electricity whenever other sources can't meet demand.
It really gets the job done.
Today we visited places off limits to regular tourists, but remember, Itaipu does offer a public tour circuit. You can learn about the plant's history, see their environmental preservation efforts, visit observation decks, speak into the control room, and even get close to the turbine shafts. Maybe you've watched this whole video wondering, wait, didn't iBird explain how Itaipu actually works? Well, I already did that 8 years ago in a really great video. If you haven't seen it yet, it's definitely worth clicking on the link shown here. And if you have seen it, I'd recommend watching it again. It's one of the best videos we've ever made.